Okay, as we continue on in this course, we're going to look at another type of unit for angles. In the past, we've seen degree, minutes, seconds as our main unit, but now we're going to look at something called a radian. Radians are very useful for a variety of reasons, and so we're going to look at what a radian is, and then how to convert between radians and degrees. And so we're going to deal with circles when we deal with radians. Often with angles in the past, we dealt with triangles primarily, but now we're going to be looking at circles as a way of representing angles. And a circle, of course, has a center. The distance from the center of the circle to the edge is the radius. And now if you took that radius and laid it out along the edge of the circle, it will trace out you'll be able to lay out a certain number of them around the circle. It ends up, if you take that and wrap it around, you'll end up, the first one here, actually I need to grab a cord or something. I have just such a thing. Right, so I'm going to take this cord. It's a white cord, so it may show up, or it might not show up really well, but I'm going to take this cord and I'm going to measure out one radius with it. And I'll lay it across the radius here, and just kind of use my fingers to pinch off the ends. Right, there's a radius. And now I'm going to wrap that same distance around the edge of the circle and kind of mark off where each one is. And what you'll see, if I start there, let's see, that's 1, and then 2, 3, 4, 5, 6, and then a little extra. So there's actually six radii along the outside of this circle. I'm going to mark them off here a little bit more clearly with my marker. Okay, so if I started right here at the at that circle at the edge of the radius, and I marked them off. So this is 1 radius, 2 radius, 3 radius, 4 radius, 5 radius, 6 radius, and then a little extra. Okay. What ends up happening is if you were to take the total circumference of a circle and divide it by the radius. So if you take the circumference and divide it by the radius, you end up with a value that's constant for every circle, no matter how small or how big that circle is. A circle as small as the end of my pen cap to a circle as big as the sun will have the same ratio between the circumference and the radius. And because it has the same ratio, we give it a name. We call it 2 pi. Now, the reason we have the 2 in there is because this is really defined off a diameter. The circumference over the diameter is equal to pi. Pi is an irrational number. It is approximately 3.14, and it is defined as this value of the circumference over the diameter. Okay, because it's an irrational number, it has decimal expansion that never terminates and never repeats. But it is a very useful number, something we're going to see quite often in this course. So pi is the ratio of the circumference to the diameter, and so 2 pi is the ratio of the circumference to the radius. And so what we end up with is that the radius mapped out 6 and a little extra of those. Okay, so 2 pi ends up being approximately 6.28. It's 6 full radii and then another 0.28 of another one, roughly, although it's an infinitely long decimal. Pi itself, if I were to do the same process with a diameter instead of a radius, I'd get it to go around 3 3.14 times approximately, although that continues as well, 3.1415, 926, and then some other stuff. So anyway, this decimal doesn't end. So these values are going to become very important. We know that the circumference is 2 pi times the radius. That's a very common formula. Circumference is 2 pi r. We also know that the circumference is pi times the diameter. Those are interchangeable formulas. Okay, well now what's interesting is that if I were to take the angle that is measured by 1 radius on the circumference, so if I took 1 radius on this arc, I would get an angle that's called 1 radian. Okay, so this angle here is called 1 radian, R-A-D-I-A-N. Okay, 1 radian is the angle that sort of swipes out a radius along the circumference. And because that's our definition of a radian, then each of these sections would count as a 1 radius angle. And of course, you don't quite get all the way back to the beginning when you do this. You have 6 sections and then 1 little portion of one. Okay, so you end up having 2 pi radians in the entire circle, right? So the entire circle gives you 2 pi radians, or 2 pi r, okay? And so there are 2 pi radians is equal to 360 degrees. So we know the whole circle all the way around makes 360 degrees. It also makes 2 pi radians. And so those are interchangeable. Those two numbers, 2 pi and 360, 2 pi radians and 360 degrees are interchangeable. It's just like thinking about inches and feet. 12 inches, 1 foot, those are interchangeable. And so this relationship is true. If I were to take this equation and divide both sides by 2, which ends up being kind of helpful, I get pi radians is equal to 180 degrees. What's nice about units that are equal to each other is that when we do a unit conversion, we divide one by the other, and we know that when we divide two things that are equal, it really equals 1, and so we're not changing anything. For instance, if I wanted to determine how many radians are in a 30-degree angle, for instance, how many radians are in a 30-degree angle, then all I have to do is convert my degrees, 30 degrees. And remember, we've done unit analysis before, so it's where we just convert by multiplying by a fraction that tries to cancel out the degrees. Of course, we have pi radians and 180 degrees, so I put the radians on top and the 180 degrees on the bottom because I want the degrees to cancel. But the pi over 180 is really equal to 1 because they're the same thing. Pi radians and 180 degrees are equal, so multiplying by that doesn't change the angle. Of course, the degrees cancel out. 30 over 180 is, of course, 1/6. Right? So this cancels to a 1 and a 6, because 30 goes into both of those numbers, and you end up with pi over 6 radians. 1/6 of a pi, or 1/6 of that pi value, is how many radians are in 30 degrees. Okay? So if you took 3.14, divided it by 6, that's how many radians are in 30-degree angle. And really, any degree measure can be converted to radians simply by multiplying by pi over 180. Conversely, if you wanted to convert from radians to degrees, you could multiply by 180 over pi. You flip that fraction over. Okay, so take a couple of examples. If I wanted to convert, I don't know, 75 degrees to radians, okay, I would do the same sort of thing. I'd do 75 degrees, I'd multiply it by pi radians over 180 degrees. 75 over 180, I could reduce that. It does reduce by 5 anyway. If I divide by 5, actually divide by 15. It's not a simple reduction. Let's divide by 5 first. That would be 15. And 180 divided by 5 would be 36, yeah. 36, and then you could divide both of those by 3, so that would be a 5 there, and that would be a 12, so it would be 5/12 pi. So you could call it 5/12 pi, but typically, radians, but typically we put the pi on top, so it would be 5 pi over 12 radians. Okay. So that's how we would do the conversion from degrees to radians. So 75 degrees and 5 pi over 12 radians are exactly the same angle. Let's try one more, but let's go the other direction. Let's start with radians. Let's say we had, for instance, a pi over 4 radians, and I wanted to convert that to degrees. Well, I start with pi over 4, and I'm going to multiply this by, now if you flip that fraction, it's 180 over pi. I'm going to leave all the units off because I know it's going to work out. But what's nice about this is the pi's cancel in this case. They don't always cancel because you don't always have a pi in the angle. But here I do, so that my pi's cancel. 180 over 4 ends up being 45. Okay, 180 over 2 is 90, and then cut that in half again is 45. So this ends up being a 45 degree angle. There are some very, very important angle conversions that you're going to need to know, pretty much have them memorized. I'll write a few of them up. We just saw a couple of them. And they come from our two special triangles. So your 30s, your 45s, 60s, and 90s. Okay, so a 30 degree angle is the same as pi over 6 radians. A 45 degree angle is the same as pi over 4 radians. 60 degree angle is pi over 3 radians. And a 90 degree angle ends up being pi over 2 radians. Okay, so these 4 I think are going to be very important for you to know. And then of course you have, your 180 is pi radians and 360 is 2 pi radians. So those are a couple other ones, but these 4 are going to be very, very important. And so we know things like the sine of 30 degrees because we can calculate trig values on these angles now using our special triangles. Remember, a 30 degree angle, if I had a 30, 60, 90 triangle, 1, 2, and root 3 are the sides. The sine of 30 is opposite over hypotenuse, that's 1/2. Well, in a similar way, the sine of pi over 6 is also 1/2 because pi over 6 and 30 degrees are the same thing. It's the same angle, as long as you're dealing with radians here and degrees here, okay? We usually write in the degree symbol for degrees, but we usually leave the radian units off and just not write the units there at all if it's in radians. So if it's in radians, there usually won't be any units listed. If it's in degrees, we do, okay? So just kind of get an understanding of that. A couple other things here. So you can find trig values then of all the radian measurements just by thinking about them in terms of their degrees and then using the same values. A couple things to remember on this list, a couple of little tricks. First one is the 30 and the 60. Notice that 30 degrees is pi over 6 and 60 is pi over 3. The 3 and the 6 switch places, right? Also the 45 is pi over 4. The 4's correspond. So the 3 to the 6, the 6 to the 3, and the 4 to the 4. Okay? So if you remember that kind of pattern, it might help you to memorize those and become very familiar with them quickly. The 90 is pi over 2. That's just one you're going to need to know. It's half of the 180. Remember, 180 degrees is pi radians. That's a really messy looking pi. There. 180 degrees is pi radians, so 90 is half of that. Right? So it's pi over 2. All right, so just a couple things to keep in mind here. I think that gets you through most of this discussion on radian measure, just the conversion from one to the other using either pi over 180 or 80 over pi, depending upon the direction of the conversion.